Why is spacecraft radiation shielding so hard to design? Imagine trying to build a shield that can stop the most energetic particles from space while keeping the spacecraft light enough to launch. That's the challenge engineers face every day. Space radiation is made up of galactic cosmic rays, solar particle events, and trapped radiation belts. These particles are mostly high-energy protons and heavy nuclei that can easily pass through many materials. When they hit shielding, they can cause nuclear reactions called spallation, which break atoms apart and create secondary radiation like neutrons and electrons. These secondary particles can be just as dangerous as the original radiation. Traditional shielding uses thick layers of aluminum or other metals. But to block high-energy particles effectively, these shields need to be very thick and heavy. For example, a shield that can protect against galactic cosmic rays might weigh several tons. That's a big problem because rockets have strict weight limits, and adding more mass costs more money and time. Every extra kilogram means more fuel and higher launch costs. Active shielding is another idea. It involves creating electromagnetic or electrostatic fields to deflect particles away from the spacecraft. But these systems need enormous amounts of power, sometimes tens of gigawatts, to work against the strongest radiation. Currently, that kind of power is not practical for space missions. Plus, designing stable electromagnetic fields that won't harm the crew or interfere with spacecraft electronics is still a work in progress. Researchers are also exploring new materials. Hydrogen-rich polymers can absorb radiation better and produce fewer secondary particles. But integrating these materials into spacecraft structures is tricky. They need to be strong, durable, and multifunctional, which is hard to achieve at the same time. For astronauts, radiation exposure can cause DNA damage, increase cancer risk, and even affect brain functions. On the International Space Station, crew members use shielding and retreat to better protected areas during solar particle events. Future missions to the Moon or Mars will need even better shields to keep astronauts safe during long trips. In the end, designing effective radiation shields is tough because it's a balancing act. They must be light enough to launch, strong enough to protect, and capable of handling complex interactions with space radiation. Ongoing research into new materials, active shielding, and real-time monitoring aims to make space safer for everyone.